Um, cool. Okay. Who wants to start us off this week?
I can go first.
Right.
I'm going to volunteer. I've been working on, I got a few things on Discretize, a few bugs, fixes in there. I helped Sarah DeVries a while ago about, there's a little bit of a bug in reading in 2D model files, UBC 2D model files. So I just switched the implementation around that should work a little bit more robustly. I wasn't really quite sure why it was breaking, but I just did something that was a little more robust. Been working on the line current source pull request. That's probably about a year old at this point. Just trying to get it back into simulation because it's got some nice stuff in there with regards to octree stuff, because it can implement the line current on an octree mesh. I feel like that'll be important moving forward. I don't know. Other than that, just I'm trying to keep up with pull requests and everything going around. That's about it.
There's about the Discretize on CondaForge. There's a cool option now on CondaForge, so you can have it auto merged.
Oh, nice.
I enabled that on my repo, so you have to make an issue with asking in the subject, asking the bot to enable auto merge.
Yeah, I've seen that part of it too. And it shouldn't be too bad now going forward, because I don't imagine the dependency is changing very quickly.
Yeah, and the good thing in CondaForge, you can even then release a new version, just increase the number which you count on PyPI. So even if it breaks. Yeah.
Yep. The other thing is I got to figure out why the source, like the discretized source, is not getting uploaded to PyPI. So I'll figure it out at some point. If not, I mean, at this point I've been just manually uploading the source code. All of the wheels get uploaded automatically, or all the Windows wheels get uploaded there.
Oh, it's probably something in the Travis file, because the wheels are coming from out there.
Yeah, and even so, it's like even after it uploads the wheels, like the AppVeyor build fails, and I'm like, okay, but it uploads the wheels. So I was like, whatever, it does what it's supposed to.
Okay. Yeah, fair enough. Actually, for going through CI stuff, I always go to Leo's his CI repository in Fadiendo. He's like very well organized. So if we need to debug stuff, we can go grab some ideas from him.
That's good. I gotta step away for a second. Sorry.
Okay. No problem. Thanks, Joe.
And it looks like Leo is actually moving to GitHub.
Oh, you take actions?
He just opened an issue today on his, I don't know if it's on Verde or another one. So it looks like he's trying to move from Travis to GitHub Actions. Yeah.
Okay, cool. Well, that's great. We can learn some more things from him. He's always so on top of stuff, so that's a great strategy. Is Leo does it, and then we'll follow what Leo does. Cool. Okay, who would like to go next?
I can go next. I don't have too much to add. I merged in the MT1D stuff into the MT branch on simulation. I've completed my tipper inversion. That's going pretty good now. I'm pretty stoked with that. It's about, let's see, I've got about 9,000 data, 101 or like 110,000 cells, and I can run an inversion, 10 iterations, 12 iterations in a day, like 10 hours or so. So it's, yeah, working pretty good. Fighting now with the other inversion where we have just a single E location and then we have a roving B field or a B sensor. Yeah, that one's it's about 24 hours and I still haven't got an iteration. So I don't know. I think it's just having trouble. So yeah, just fighting with that one. And then I was doing some benchmarking and I don't know what, got some weird things I'm going to investigate. I ran a DC inversion on a brand new Z4. So it's like, say 16 cores or 8 cores, 16 virtual or another 8 virtual. A little bit of RAM, and then I threw it on our big machine that has 128 cores, and the Z4 outperformed it. Yeah, I don't know what's going on. I like looking at, then they're both spending about the same amount of time in Paradiso, which is kind of strange because you think that it would be solving the equation or solving that side of the inverse with 120 some cores. It's going to do it faster than, say, a 8-core machine. Yeah, I don't know. It's something weird's there, and I'm just investigating it. So that's pretty much all I'm up to right now.
Yeah, the Paradiso solver doesn't scale very well.
It seemed to have before, though. I swear I tested this and it went like through the roof. But yeah, it looks like that might be the case, Joe. You're right.
I mean, as far as the factorization time probably won't scale too much, but at least if you're giving it a bunch of right-hand sides at the same time, it might scale.
Yeah. Okay, I'll just have to make sure see if I'm doing them all there at one time. Because yeah, I swear I tested it like a year or so ago, and it was, yeah, I could see the difference. It scaled, but not now. Yeah, I'll just take a look into it. That's about it. So.
Did you ever think approaching the Paradiso guys and asking if SimPEG as an open source project maybe could use a newer version for free?
Not thought of it, but I'd be willing to reach out. Is that a general consensus too? I could look into this.
Yeah, I mean, I would have liked to have gotten into the Paradiso, like the new version of it, but I'm not sure what the license is like, and it's not really open source license, but they do have they might be interested in something if we were like, oh, we would like to write some Python wrappers specifically for Paradiso or Python wrappers, because I know they publish some. They have some for MATLAB.
Oh.
Wrappers for it, but I haven't looked too much into it. But I'm also not sure how we can't really distribute it either.
Yeah.
Well, we could still distribute the wrappers, which could actually drive it off, right? Is that the wrappers can be open source, but then you have to go to them to get the closed source. That's a really good idea. Would folks be interested if we just started Google Doc and write a short letter and we'll see what happens?
We're definitely for it. Yeah.
I'm certainly willing to help with or take a lead on writing the wrappers for it at least.
That would be
I'm important to help too. I might need your great guidance though, Joe.
Okay, cool. Thanks, John. Do you have any other?
Other than that, just working on some of our back end stuff with Caravelle and whatnot. But yeah, voted.
Next. Are you going to make me call on you? Devin, let's see, you've got points in there, so would you like to?
Sure. Yep. Just one moment here. Yeah. So I guess maybe an update on that EM1D stuff. So I've gotten it to a place where we can it's pretty much in sort of our SimPEG organization. And I've got the main set of tutorials. So we could do forward modeling and inversion of frequency domain and time domain EM locally. And then I've got the stitched working. And I also was able to make I think I made sort of they can use the same survey class. So instead of being these two separate, completely separate things, you can now kind of design a survey, and then if it has more locations and the simulation is a stitched 1D simulation, it will do that. And if the simulation is 1D, it will just do that. But yeah, now I'm kind of at the point where I think I probably need some input from some other people. And one of the reasons is we can only solve the vertical magnetic dipole so long as the radial distance is large enough. If the radial distance goes to 0, it's no longer a Hankel transform. It actually can be written as a Laplace transform. And so the current filter or way that we numerically evaluate that integral doesn't work anymore. And then for the horizontal loop source, there's only one Bessel function in that integral if the radial distance is 0. But if your radial distance is non-zero, then you have 2 Bessel functions in the integral. So you have to solve it differently. So for what we have, we can compute the x, y, and z components. But when the receiver is in some different locations, we don't have those solutions yet. So I would definitely like some input on that. I played around with it a little bit. I looked at the MPy mod, and Dieter gave me some suggestions, but I wasn't really able to figure it out. So yeah, I could use some assistance on that.
Devin, can you explain when you were talking about the radial distance? What are you talking about?
So I guess let me just try and I'll find it here. Let's see, I think I know what page it is. Okay, so what you should be looking at right now is Warden-Homan. And this is going to be the radial component. This is the vertical magnetic dipole solution. And this is the radial component that you would get. And this is the vertical component of the field that you would get. So as rho, the radial distance, goes to 0, J1 will go to 0. So that Bessel function will go to 0 if what's inside here is 0. And this one, the Bessel function, J0, will go to 1 as rho goes to 0. So my understanding is that we've developed a digital filter for evaluating this integral, and the coefficients and the locations that they're being evaluated, it's basically been designed for to compute this Hankel transform. But if this goes to 1, it returns a bunch of nans. So it's not able to go and compute this integral if there's no basically oscillation or basically, I guess it's no decay in the Bessel function, because it will always be equal to 1. Is that sort of correct, Dieter?
The equations I use are different ones. That I think most codes like dipole 1D from Kerry Key or what they use is a point source in the wave number frequency domain, and then any source signature would come in the frequency domain, so after the Hankel transform. That's why you can use the same Hankel transform for any kind of survey. You always have the same kernel. So I don't have that issue.
Okay. Yeah, I guess.
You need to go to really small values of rho?
Well, in a practical sense, it didn't really matter too much, because if we were doing frequency domain, then we would be using systems where there was a horizontal separation between the transmitter and the receiver, and then we just had dipole source and then point receiver. And whenever we did, I guess, time domain systems, it would usually be a coincident loop system, which we could solve, and we would just use the horizontal loop solution. So there was a usable solution in practice for the frequency and the time domain systems that were common for airborne. But we wanted to make this code generalizable either for academic use or in case somebody wanted to test some new system. So we ended up doing, we ended up wanting to change that.
Okay, well, this is probably something we can continue on offline.
Yeah, I guess. Yeah, I mean, Soggy would be a really good person to be involved in this, or anyone else who wants to, but I don't think I'm going to make a lot of progress on this quickly without some assistance. So I would hope somebody else wants to be involved.
Okay, I can probably offer something, but not off the top of my head. It's been a long time since I've thought carefully about these things. And Soggy will have done too, so.
Yeah, I mean, it's all, the framework for doing this is all set up. I'm either making an error on the syntax, or there's just kind of a detail. I'm sure someone who's a bit more familiar with it could look at it and implement it in an hour or two.
Where do you want to have that discussion, Devin? Do you have an issue going, or a Google Doc, or Slack, or yeah, where would you like that?
Yeah, I haven't completely outlined all of it, but I'm looking to do that because it's more than just this. It's sort of at the time where probably should get an input from the group and come to consensus on the direction before we get into some of the, I don't know, the fine details. It's sort of a good time. So maybe I'll draft something up, put it somewhere people can read through, or maybe I'll just make it in the as issues or something in the repository. So I'll just kind of document all the things we'd like to get done before moving it into SimPEG.
Yep, sounds good. I'm happy to have a look.
Yeah, that would be great. So yeah, that's basically it for me.
Thanks, Devin. Cool. Anyone want to go next? Peter?
Yeah, that's gonna be a quick one because for me, after Transform, it was another conference. Well, not a conference, but we had the consortium meeting, which kept me busy, and then following up stuff on that and proposals. So nothing interesting to share, or not yet, at least.
Fair enough.
Yeah.
John, do you have any updates?
Nothing on the nothing on the core SimPEG library. I ran more inversions, I guess trying to run inversions with the spectrum data, which has been challenging, but trying to get down the details with that. And then we had a meeting last week, I guess, with John and Diaz people who tried to start thinking about having more general input files for inversions. I think that's something that we'll have to work on over the next month, and might influence and might have an impact on other people here in the channel. So we'll keep you posted as we go. And then yeah, that's it. That's it.
Thanks, John. Yeah, I would be very keen to sort of at least even just keep a pulse on those conversations about input files, because I think as we think about sort of like high level wrappers and things like that for SimPEG, we might have some thoughts to offer just in terms of making things pretty interoperable and hopefully easy to go between. Yeah, that's cool. Cool. Thibaut.
Yeah, well, nothing on the SimPEG core either, but yeah, I'm seeing the end of the tunnel. Yeah, like the thesis is, as I said last week, was like in the end of my committee at the moment. The case study paper is in production, so I figure like interpretation has some weird policy, and GeoSci.xyz has some weird policy that I was not aware of for production in terms of figures and colors. So it's all in production now, and with Lindsay we submitted the revision of our joint inversion paper too. So yeah, woo. So yeah, now it's time for me. Like I'm thinking about the next projects. It's like maybe play with GeoSci and PyTorch again, or work on another case study. So that's kind of what's I'm gonna be up to in the next few weeks. Also, it's a call to everyone that was at UBC. I'm planning on updating the GIF website because we haven't updated the list of publications since 2017. and when you search for our paper in Google, it's often the first website we found. So if you want to send me your preprints and an associated bib text for the reference for them, I will try to update the website publication page in the next week or so.
Thanks, Thibaut. That would be great. That's a great avenue for sharing all this work. Is there a spot also? I don't know if this is hard to do. If it is, that's fine. But to put GitHub with those publications, because we've been, at least recently, you know, with a lot of the publications we've done for the code, we've put them in the SimPEG research organization, and it would be nice to have a link there. So I don't know if that's an easy thing to do on the site, but if it is, that would be pretty cool.
It's a great idea. I admit I've never opened the website interface on how to changing so far. So that's gonna be a very first time. So, but that's a great idea. I agree with you.
Is that's the UBC GIF website? Like you would be able to download all of the proprietary software. You're talking about that website, right?
Yeah, like so on that website there is a publication page, and when you look for one of the GIF paper on Google, it's often the first result. And also it's an easy way to get the paper for free. Like know that don't have like access to the SCG publication, or so you have the preprints there. So okay. I think it's a great avenue for the visibility. So that's the website I'm planning to update, but like I'm not changing the layout or your download stuff. I'm gonna focus on that particular page.
Yeah, I was just gonna say, if you have some questions or you have any access problems, let me know, because I think I'm the person that has all the fancy powers to give you access. So hit me up if you have issues.
Okay.
Thanks, Thibaut. Doug, do you have any updates?
No, not really. I'm glad, Thibaut, thanks for doing that. That's been a long time that things have languished, but it'll be nice to get that updated and just to have a collection, even just for ourselves, to remember which papers we actually published. Sometimes you forget.
And have access to them in case you publish Elsevier and you can't even access your own paper.
That's true.
Yeah. Yeah, so people just send me your preprint and bib text, and that will be with that I will be able to put everything online.
Thanks, Thibaut. Cool. Okay, I've got a couple updates. Where to start? I guess one is on the Swung Slack channel, there's a bit of discussion happening about should we think about having either a shared channel between SimPEG and Swung, or should we just merge and have like SimPEG channels in the Swung organization? And so I just wanted to raise that and have folks think about it. I don't think we need to make a decision right away, but there's potentially some benefits. I know a lot of us are in both, and so it would be one less Slack channel to monitor. And like also sort of having direct connections with folks in GenPy, with other projects could be nice. So something to think about. And yeah, I don't know if anyone has initial reactions to that.
Sounds great to me. It will be better to have cross-pollination if people that are on the software underground can also see SimPEG just by default, right, as a channel. I think that's a good idea. And
we could still have, I think, multiple channels, is basically have like transfer almost everything over. We can take a look and see which ones we're actually still active with, because some we're not. But to get like SimPEG general, SimPEG discretized, SimPEG whatever, so that it's still sort of like the same general structure, but now actually with a much larger community.
Might be worth check, because I think it was Leo who asked that first, right?
Yeah.
So it might be worth checking with him if he plans to actually do it or not, and if he does it, then then more and more communities would get in. Yeah.
That also raises a question that we should think about, is because right now, like Swung is actually a paid Slack group, so all the data is like that. but there's now ways to actually help support some of that. And so if we go in as a SimPEG community, it might be nice if, like through UBC, maybe we could put in a bit. I don't know if Diaz would be willing to put in a bit, or Dom, if Mira would be willing to put in. I mean, I don't think we need to be funding a huge amount, but if each group could put in $100 a year or something like that, that makes a big difference, because I think it costs them like thousands. And so if we're going to do this, I think like
not anymore, because it has now the NGO account from Slack. So I think 80% are paid, are off. So it's not that expensive anymore.
Okay, that's great.
Since it's an NGO, yeah.
That's great.
But it would definitely be one of the advantages to be in Zwang, that all messages are visible, because now we can't see our old messages.
Yeah, that's good to know. And so actually I can, if we are going to do this, I'll just ping Matt and actually ask if he could give us basically what would a reasonable, if we're bringing 200 people in, how much should we be paying you? And then we can try and sort of distribute that amongst ourselves, or amongst like the organizations that we're in. Cool. Okay. The next thing that I wanted to mention is with the paper that we're working on, Dieter, I've been running some SimPEG examples trying to compare sort of the benchmarking with other codes. And this again comes back to the solvers, because it's annoying that, you know, basically like the bottleneck or the compute time is completely just down to what solver we're using. So in some senses, it's like, it's not really a code comparison, it's like a solver comparison, but that's okay. And so I've been working on playing around quite a bit with the Octree codes and really trying to tune the first just layered model example. And so if anyone here is actually willing to just take a pass at it and see if there's any other little things you could see improving, ideally accuracy, but also, you know, looking at potentially reducing compute time, I would appreciate another set of eyes on that. Most of the codes are sort of in the like 1 to 10% error is what folks have been hitting. And right now, my sort of best hand tuning, I'm about the 10% error on average. And we should be able to drive that down. But again, it's probably some bottlenecks basically with Paradiso. So yeah, would anyone here be willing to take a pass and just fiddle around with this or interested in that?
What is the example? Like, what are the setup, Lindsay?
So it's,
wait.
There's no worries. There's 3 examples that we're looking at. The first is just a layered Earth model, and we're comparing with EM-PyMod. But it's layered Earth.
Like what are the sources and receiver? What are, like, it's like a CSCM survey?
Yeah,
or
CSCM survey. And we're looking at electric field receivers. So it's a marine CSCM example. Layered Earth with anisotropy. And single source and multiple receivers for the first example. And then with that example, so we've got the layered Earth, and then we'll introduce blocks into that example, so it becomes a full 3D example. And so I'll use basically a very similar mesh design with the Octree. They'll be slightly different because I don't need to introduce extra refinement around the blocks in the layered Earth. And then the second example is based on the Marlum model. And so that one I'm just getting started on. The base sort of tensor mesh has like 90 million cells, I think. Is that right, Dieter? Yeah, and so the first problem is really, can I design an Octree mesh that is feasible for solving this problem? Ideally with a direct solver like Paradiso, but we might need to switch over to iterative to handle that. So I'm just getting off the ground with that one.
Okay.
But go ahead, sorry.
Is in time domain, frequency domain?
Frequency.
Okay.
Yeah, and with that, I think we've got 5 frequencies we're looking at.
Right, and then it's in the marine setup.
Yeah.
I think one of my concern, like a lot of other codes, use the primary, like secondary field approach.
All 4 codes are total field now.
Oh, okay.
Custom always had total field. PetGem just introduced it shortly before we started with that. I'm using total field, and I think SimPEG as well, right?
Yeah.
Oh, really? Okay, cool.
I see your concern that it's one way, it's a solver comparison, so it's Phoenix, PET-SC. In my case, I'm the solver as well, and then in SimPEG it's Pardita. But I think you should emphasize in your text, because we also should lay out what can these tools do otherwise, and that's where you have to put in all the stuff from SimPEG that they can do other methods, other things. The user interface, which SimPEG has much more than any of the other codes, also examples online, all that stuff. And also, I mean, I think it's really exciting that there are different meshes, because the other two codes they have a tetrahedral meshes. Then I would have just a regular tensor mesh, and you would have octree meshes. So I think that's really an exciting point to see these differences or similarities.
Yeah.
So I don't think it's just about memory and speed. It's also just to see the different code that are out there and can do it, and what are the different approaches to do it. Yeah.
And
really cool comparison, and it's definitely been a great learning experience for me too, getting a sense of what things can you tune in the octree mesh to get better accuracy. So, and Sagi, were you gonna say something more?
No, I was just kind of curious what's their setup like. So all codes are total field formulation, and are they using sort of bipole or like electrical dipole as a source?
It's a good question. Custom has a lot of setups, so they have total field, they have primary, secondary field, and some potential approaches. I think Custom has a lot of different approaches, and he's working at the moment also on time domain, where he's now making a paper for ASU, Euler, and other methods. Actually, I think he implemented 4 or 5 different time stepping methods. I think he has a lot of things, but I don't know the details. There will be, if you want, I can send you the link to the main Custom paper if you're interested, because he made a comparison of a lot of different approaches to solve it, which is sort of interesting. PetGem, I think, is just using PET-SC as a solver, but I don't know. Yeah, but it's just basically the other two codes, and also it's mainly CSEM in contrast to SimPEG. So it's mainly CSEM. Yeah.
Right. In a marine setup.
Not necessarily. Can be land as well. Yeah.
Okay. But the example is a marine setup.
In this paper, yeah. I think it's the easiest to compare, because then otherwise you introduce so many more causes that could be different because of topography and how it handles. I think, yeah, it makes it a bit easier to compare somehow.
Right. And Lindsay, you're getting about 10% error. Is that what you're getting?
About that, yeah.
Yeah, so that seems a bit big. I think the Marine EM, I think they are aiming for 1%. I guess that's sort of what I remember when they're fitting the data. So yeah, it's too large. I'll take a look.
Okay.
But also for your first pass, Lindsay, I mean, if you know it works, then we can continue, and you still have a month or two.
Yeah, no,
that's cool that it works. That's cool.
Yeah, no, I'm encouraged that it's the setup is working pretty well, and I mean, these simulations aren't taking too long to run, so so yeah, we still have space to play and improve.
Cool.
Do you mind if I share the repo, because I think it's still private?
Yes. Let me ask the guys to not. That everybody's, I wouldn't have a problem with that. I could have had it open from the beginning, but sometimes. So let me ask them, and then we might open it.
Okay. Yeah, because I'm totally fine if we open it, but I appreciate, whatever they prefer.
Yeah.
I had another. Oh yeah, 2 other thoughts with that. One was just like, and this is maybe a question for later, is where we actually want to put that repo later on. is it could be a cool opportunity to maybe think about either using that open geophysics org, or if we want to do something with SWUNG, where there's like a SWUNG research org. I don't know, it's just one question to kind of put on the radar.
Yes. Yeah.
Oh yeah, and then the last thing is that this actually really nicely aligns, I think, with the motivation of the Jupiter Meets the Earth project, which is like basically trying to advance sort of Jupiter technologies being driven by scientific use cases. So one of the things that I raised with Fernando today, and will hopefully bring up at the next meeting I have with folks from NCAR, is that they're actually looking at creating like a binder for HPC. So if you had, so like we could potentially actually put these examples on Cheyenne, the big supercomputer run by NCAR, and be able to send out links to people, which I think would be really cool. And so I will keep sort of asking about that, but I just wanted to share that I thought that it was like potentially something kind of exciting that we could do to elevate this and have other people be able to go in and play with things. So. Cool. I don't know, does anybody else have any other items you'd like to chat about or bring up?
What was you guys' take on? So I'm not gonna go for sure to Houston. So I know that you guys talked a little bit about it at the end of last meetings. What's the consensus? Anyone wants to take over the SCG presentation, or what are we doing?
So one of the things we brought up, and I don't know if this would fly with SCG, probably not, but that's fine, is do we actually just want to do our own thing and like ask Matt and others at SWUNG if we could just do something like transform, like more like that style of workshop just on our own, but potentially in that same time slot. Yeah,
you can ask SCG, but I have the feeling that that's their cow, right? That they try to milk every year, and I don't think they'll fly. Like I tried many times to email them and ask them if we could go full online, and they're still digging their heels with this hybrid approach. So
yeah.
Unless anyone like raised their hand and would say I wanna commit to go to Houston and like house this thing, I'll just email them and tell them that we're out. Dequan is out for sure. He's not gonna go down. I'm not gonna go down. So it's okay. We don't have to do it. We just need to be clear, right? They have like 2 or 3 months left of prep.
Yeah. No, I think that the hybrid approach sounds, I think you're going to end up getting the worst of both worlds.
It's the worst approach, right? Like who's really going to learn anything? Having a videotape thing and then answering questions after. This is not a tutorial. This is like this is a sales pitch.
But it does raise for me the question: do we still want to try and do our own targeted tutorial for industry, like irrespective of SEG? Or do we want to just hold off on that?
I think we should. I don't have the bandwidth to do it myself. And I would say if we do this, we should be targeting exactly the methods that we want to cover and just, going deep into it. Because I'm not sure people are getting much out of it. If it's just like general SimPEG, it needs to be applied. And like today we're going to meet and we're going to do mag inversions. Tomorrow we'll meet and we'll do, EM1D, that kind of stuff. I think works if people are, ready to go. But just general tutorial about talking, it's great, it's exposure, but I'm not seeing the huge time investment, like big return on investment. That's my opinion.
That's really fair. Okay, well, it sounds like, pulling the plug on SEG is, Sonia, you didn't get a chance to say anything.
I don't have anything particular. So I was actually working on the revision of the paper about power line effect and the steel casing. Got a lot of revision. Remember the Ben Bloss when we went to Denver? He gave a talk in what was that? In disc lab, right? he was actually the reviewer, and he made like tons of like zillions of questions, which I just finished to answer. But actually, I made his work kind of sort of more reliable. That's it.
Yeah, and Ben Blau's did his master's thesis was on power line transmission.
Right, which was actually very helpful for me to move on.
He's an interesting guy.
And actually, thanks, Lindsay, because a lot of reviewers are asking, oh, how do you prove your accuracy of the code? It's such a large contrast, so I just cited yours. They compare it with the state-of-art code, so I'm good to go.
Excellent. Well, I'm glad you can, yeah, those things are always tough questions, so it's nice if you can just cite somebody else did it. So I'm glad that's useful. Cool. Okay.
I don't know if maybe, Devin, you want to quickly repeat so Soak is on the same page? Or are you just going to ping later on?
Yeah, I guess I'll get to it sometime in the next week, and then I'd just sort of send out a message that says, okay, I've organized it this way, and provide links to everyone. Yeah.
Cool.
What is it about?
It's about the EM1D stuff, so I thought you might actually be interested in it. Mostly that for the frequency domain EM systems that we usually use, we can use a vertical magnetic dipole. We have a way of computing the integral, but only if the radial distance, like the radial offset, is large enough. So if you had something you're trying to do where the transmitter and receiver were vertically separated, we can't, right now we can't compute that response.
No,
because
it does.
Really, it throws out a bunch of nans for me.
I think you probably need to be careful, because that's only when you put the receiver in the ground. So it only works when the receiver is above the ground. So it doesn't work. So everything needs to be in the air. But long as,
yeah, that's what I did it. Yeah.
But yeah, I mean, there should be something wrong, because what I'm doing, let's say SkyTeam, for instance, your source is here, the receiver is slightly up. And what Dom did for Spectrum is similar. You have sources here, receiver is like far apart and down. So I mean, like it should work. So I don't really see there's a problem.
Starting to make me think that maybe the coordinate system in there is not standard SimPEG then.
No, it's not.
Okay, well that would be a big one.
So yeah, it's that I'm sorry about that. That code has a lot of nonlinear weird setup, but it's supposed to work. Sorry.
Okay, so that solves one of the problems. The other thing we would like to solve is the horizontal loop. We can solve that for a zero offset. We can do a coincident loop system, but if you have the solution for a circular horizontal loop, and you have a non-zero horizontal offset, you have two Bessel functions in that integral, and that's a much harder problem to solve. I did it once with like an adaptive quadrature method that MATLAB uses, but that takes quite a while, and it's not always the most stable solution.
We can get some help from Dieter. So here's our best expertise about what is it, Legendre Bessel integral or something like that. So yeah, it's on my bucket list, because yeah, it'll be nice to handle like an EM1DFM where you define the wire path, and then you can put wherever your receiver is. So it's on my list, but yeah, I just didn't have a time to work on it.
Yeah, so I guess you missed the first part of the meeting, but I've basically taken the EM1D repository and I've adapted it so that it has a more SimPEG-like framework. And I have tutorials, like the main set of tutorials for everything, local and stitched, FEM and TEM inversion, playing around with some different waveforms. So there is now a template to really go in and test and see if it can do all the stuff that we want it to do. So I was going to summarize the main issues that I had, and what would be good to get input from the rest of the group. But it's now at that point where the initial work of it is done, and now we're kind of in the next phase of it. So
right, it's great that you got a good structure. Oh yeah, I can jump in and have a look. Also, let me know if you have an example where you have a problem. I can take a look.
yeah, well, I'll see if using correct coordinate systems will maybe make that. For some reason I thought that it wouldn't. I was surprised that the solution wouldn't be stable because I had an exponentially decaying function already because there was a vertical separation. So I was surprised that it was giving me out a bunch of nans, but that would make sense. I guess what I had before, it was the Bessel function that was decaying fast enough. Okay.
Yeah, we might want to make some notes because yeah, the MT now it's going to be the 3D stuff is all SimPEG orientation, but the MT 1D has Z down. Is it, Devin?
No, it should be a plus I omega T Fourier convention, and it should be X is east, Y is north, and Z is positive upwards. And you can figure out which is which by looking at what looking at the ZXY. You can look at what quadrant it is on the complex plane. It should tell you.
Okay. No, like I have all the inputs working. It's just I thought you had it reversed, but I guess I reversed the reverse.
Yeah, but we have some correspondence on Slack where you asked me about this, and I think I explicitly have it what it's doing, and I used that Nepal 1D sounding data and inverted that to kind of verify.
Okay, yeah, and then we've been able to do the same thing. So okay, yeah, I guess I just still got confused.
Yeah, it's confusing a bit, but yeah, it should be X easting, Y northing, and Z positive up because we brought it up in a conversation maybe 2 months ago.
Yeah.
We all came to consensus and just said SimPEG is going to be this way, like period. So yeah, that was designed that way.
Okay, fair enough. I could have sworn you said it was standard MT, like the EDI file. So yeah.
Yeah, I mean, one of the nice things though is that derivation, regardless of whether or not it was northing easting down or east northing up, I think it ends up actually being the same because they're both right-handed coordinate systems.
Okay.
But I'd have to check that.
Yeah. Well, what I got worked out seems to be the right one. So, and it looked, and when I confirmed it was the right hand rule, all the same. So okay, we're good.
Yeah, well, I look forward to playing with the 3D MT stuff. I think I could maybe add some value there.
Yeah, that would be fun. That'd be great.
Cool.
One other quick thing just to note for everyone, I think AGU abstract deadline is coming up sort of soon. And so if you want to, if you're thinking about anything and want support from anyone in the SimPEG team, it'd be fun to have a few abstracts in there. I'm running a session again on open source software, like the lightning talk tour that we've done in the past years. So too, if you have anybody in mind who is perhaps newer to the open source software world that would be great to highlight, it would be great to get suggestions because we get 2 invited speakers and we try and make sure it's not just like, the same faces all the time or sort of the big projects that everyone already knows about. It's nice to use it as an opportunity to highlight other folks. So if you come across a project where you're like, this is cool, I want to hear more about it, just let me know and we can invite them as a speaker. So. Perfect. Dieter, were you saying something? I can't hear. I think your mic is up.
Maybe that is better. In that respect, I haven't put it in our channel yet, but I thought the comparison paper we do with custom and PetChem, we should write an abstract for that. Which might be a good fit for HU. Yeah. I'll post it now with the question about opening the repo and yeah.
Okay, well, thanks everyone. Have a good afternoon, and we'll see you next week again on Slack.
Thanks, guys. Bye, everybody.